Believe it or not, this is the last day of chapter 9 notes. I can't even believe it. It went so fast. It was so fun. Thank you. So tomorrow we're going to start reviewing. Then we'll review one more day, and you actually have a test on Tuesday. So yeah, it's real quick, no breaks for quizzes. We're going right for it, and then we'll start studying for finals. Okay? Shh. Hey, too much chitter chatter. Knock it off. All right. Today we are learning how to solve these using the elimination method. So the key to the elimination method is to get rid of one of the variables by adding the two equations together. Some people call it the opposites method because the trick is to get opposite coefficients on one of the variables. So do you see how right now y has a positive 1 for the coefficient? And this y has a negative 1? So if you add those together, you end up with no more y's. Does everyone see that? 1y plus negative 1y is no more y's. It eliminates the y's. That's why it's called the elimination method. You can add everything else too. So x plus x is 2x. X plus x, 2x. And 3 plus 1 is 4. Now you have an equation, hopefully just a one-stepper, that only has one variable in it. How would I find the x here? Divide both sides by 2, and you would get 2 for your x. Now, do you remember when we did substitution, there was always a nice place to plug the variable in where the other one was already isolated? That's not as simple in the elimination method because you're not required to get any of the variables alone. So just pick whichever one looks easiest. It doesn't really matter. I'm going to plug it into the top equation. I'm just putting this x back in to find the y.
Y equals 1.
I took x out and I put the x value in. Now I'm just solving for y. So y equals 1. So my solution here is 2, 1. If I graphed this, these graphs would cross at 2, 1. Or if I got this x by itself and plugged it up in here for this x and then found x and y, I'd still get 2, 1. Whichever method you use to solve, you should get the same answer. And when you plug the answer back in, you should get two equations that are true. What are your questions? Here is part B. Sometimes we don't have opposites already, and then we need to make them opposites. Okay. All right, so what should I do here? Eliminate the y. We already have opposite coefficients on our y's. So we are actually ready to add the equations. So when you do this, the y's go away. What's 4x plus 2x? 6x. What's 11 plus 13? 24. Divide both sides by 6 and you get that x equals 4. All right, once again, you can pick either equation. If one of them doesn't seem a whole lot simpler than the other one, I usually just pick the first one. So I'm going to start back with this equation. I'm going to plug the 4 in for the x. Now I can solve for y. All right, what's 4 times 4? 16. What's 11 minus 16? Huh?
5.
Negative 5. I just subtracted 16 from both sides. And then we have to do what? Divide both sides by? Negative 3. What's negative 5 divided by negative 3? Just 5/3. Good. So my answer is 4, 5/3. Don't forget the parentheses around these. These are all ordered pairs. Questions? All right, do I have opposites? I don't. So when you don't have opposites, you can make opposites. So right now I have one R and one R. So if I multiply one of the equations by -1, then I'll make opposites. Does everybody see that? Okay, so my plan of attack is to multiply 1R plus 4S equals 11 by -1. Now I'm ready to add the equations. What happens to the R's? They cancel out. What happens to the S's? What? You're just saying cancel out. You're not even listening. What happens to the R's? They cancel. You get 0 R technically. What happens to the S's? You get -10 S. And then here's, I don't know why people always get real stumped with these. What's positive 11 plus -11? 0. Does this make no solution? No. I still have a variable. You can have an answer of 0. That is a solution, okay? Sometimes when we get 0 on one side of the equation, students just kind of lose it a little bit. Don't be that person, okay? You can still go through and divide both sides by -10, and we get an S value of 0. All right, go ahead and plug 0 back in for one of the S's. I'm going to go with the S in the original first equation. What's 4 times 0? 0. R equals 0. All right, alphabetical order, the 11 goes first, then the 0. What are your questions? All right, here's D. All right. What should I do? Why would I multiply by -1? What? To get opposites. So right now, if I added the equations, I'd get 6x plus 10y. That's not helpful. I haven't gotten rid of anything. So I can't add yet. I need to get opposites. They both have 3's. I want one of them to have a -3. So I am going to multiply the entire first equation by a -1. That gives me -3x minus 4y equals -19. Now what? So we add these. What's 6y plus -4y? 2y equals, what's 33 plus -19? 14. What's y going to equal? 7. Then what? Plug it back in. So I have 4 times 7. 28. So 3x plus 28 equals 19. Take away 28 from both sides. 19 minus 28 is negative 9. Divide by 3. Negative 3. So we get negative 3, comma 7. There are 10 examples today, I believe. This would be the 4th. I don't know if we'll get to all of them. I really want to show you guys this, my favorite, my honest favorite YouTube video of all time.
Is it a math YouTube video?
Yes.
Is it a song?
Yes, it is. Okay, we got to keep going though. Your teacher sounds awesome. All right. So I don't have opposites. I don't even have the same coefficient. Yes.
I'm guessing that you're going to have to multiply the bottom one by negative 2.
Yes, so there's 2 ways you could, there's actually lots of combinations that would work. That would be one of the options. She said, can we multiply the bottom one by negative 2? That would get 6x and negative 6x. I don't think that's the way I did it on mine. I always try to keep the numbers as small as possible. So yes, if you do it that way, you're going to get the same answer as us, but that's not the way it's going to appear on the board. Just because I want to try to keep the numbers a little bitty. So what's the smallest way? Negative 2. I need this one to be a negative 2, this one to be a positive 2. So I can multiply the top by a negative 2. So I do negative 2 times 6x, that's negative 12x. Then I do negative 2 times positive 1y, that's negative 2y. Don't forget the other side of the equal sign. 6 times negative 2 is negative 12. So some of you might want to do like this guy, you know. Okay, now I have opposites on the y's, so let's add them. What's 3x plus negative 12x?
Negative 9x.
And then the y's are gone. What's 9 plus negative 12?
Negative 3.
So I have negative 9x equals negative 3.
Negative 3 over 9.
Yes, careful here. Divide both sides by
Negative 9.
negative 9. So negative 3 over 9, sorry, negative 3 over negative 9 is positive 1 over 3. Now what?
Plug it back in.
Plug it back in. I'm going to plug it into the original top equation. What is 6 times 1/3?
3.
2. It's like 6 divided by 3, which is 2. So what's my y equal? 4. Very good. What are your questions? All right, and it's 1/3, 4. Okay, I am gonna rapid fire this one. Don't write it down. Stop. Pause. Close your eyes. Okay, now. We're doing this one. Okay, so the reason I wanted to jump into this one is because there are no coefficients from one that can multiply to make the other. You know what I mean? Like you can't turn a 4 into a negative 6. You can't turn a 2 into a positive 3. So we're going to need to get a little deeper on this one. Any ideas? Yes.
Times the top by 3 and the bottom by 2.
All right, she would like to multiply the top by 3 and the bottom by 2. Why? What's the point?
To get them the same.
What's them?
The numbers. 4 and 6.
The y's. That would give me positive 6y here and negative 6y here. That's the point. So I need to multiply the entire top equation by 3 and the entire bottom equation by 2. Those are my two new equations. I will pause here for a second. All right. Now what? Yeah, go ahead and add them. What is 18x plus 8x? 26x equals, what do we get on the right side? 13. So x is going to equal 1/2. Which isn't going to be terrible because look, our coefficients are both even. So go ahead and plug it in to one of the equations. I'm going to go top equation.
Can you go back to the, like, are you allowed to do that? Go back to the original, plug it back in.
I plugged it into the top original equation, yeah.
Oh, so you put it.
Are you done? Just the bin's fine. Thank you. Yeah, where else were you trying to plug it in?
I thought you had to do it to the 18x plus 6.
Nope, you can go back. I actually prefer you go back to the original because it's usually smaller numbers, so you're less likely to make mistakes. All right, what's 6 times 1/2?
3.
Good. Then what? Minus 3 from both sides. Divide both sides by 2. So my answer is 1/2, 3. Do you guys have any questions? Do you want to stop here and watch the world's greatest YouTube video, or do you want to do more examples?
Video.
World's greatest YouTube video. Okay, let's summarize these.
Wait, so we're not doing this tomorrow?
What? I'm giving you your homework after we summarize the notes. Hey, shh, shh. What do we learn about today? Do you know the answer? Okay, hold on. What do we learn about today? The elimination method. And we have successfully completed the last day of notes for this year. I know. Next time we take notes, it'll be 2019.